Hi, welcome back to our webinar series on drones and UAVs. This is Tom Moran with the All Hazards Consortium, and on behalf of the Multi-State Fleet Response Working Group, we've invited Kevin Gambold, the CEO of Unmanned Experts, to join us here. Kevin, this section of the webinar is going to look at use cases and threats. This is a fascinating discussion that we're going to be having, on a webinar coming up in several months. But I wonder if you could brief our audience a little bit on some of the use cases you've seen and the threats, and more importantly, is how do we work against the threats. So I'll turn it over to you, Kevin. Go ahead.
Yeah, thanks ever so much, Tom. And we're going to be looking at the good side of these, and then we'll drift later on in webinars to the bad and the ugly. So there is a tremendous amount of utility in these things. And in fact, what the military found, because they've been the predominant users of them, is that there are very few areas in their day-to-day operations that couldn't benefit to some extent in what UAVs can do. And we're finding this now with the commercial sector. So let's say you buy them and all you want to do is inspect a power line. Well, that's pretty good. You've got the sensors, you can use LiDAR, you can map it, that's all good. But then you go, we've got this bridge with one of our gas pipes under, and we can't get under the bridge. Oh, well, you can with the drone. Oh, wait a second, we need to map the outside of this substation facility. Well, you can map it in 3D in a matter of minutes with a platform that you already own. So, and it goes on and on. And like I said, there are some incredible use cases. This drowning victim this was developed in Iran. And in fact, there's some video that actually being used. So, whether it saves anyone, we don't know. But let's be honest, that you never know. And if you're drowning, I'd rather have this thing drop one to me than have a guy trying to swim through the riptide to get me. Good. So let's move. All right. This is a tremendous example which happened earlier in 2015 this year, and there's a video attached to this which I'll ask Tom to post as a link. You really must look at it, but I'll talk you through what the video will show. The video is taken legally, effectively, because of some of the regulation rules that I mentioned previously. However, you see a car in the foreground here. You can't get anything except a boat out to this area. 8 inches fell, covered the entire state 8 inches deep. Enough rain fell here to completely paralyze the city. This is Houston. And so we needed to, if you need to know what's up some of these side streets, the easiest, quickest way is to pull a drone off your backpack, fly it out there. You can beam that video back to police headquarters. You can get that to the Red Cross. You can see who stood on their roof waving for assistance, and then you could bring the helicopter in. So the utility is staggering. I recommend you watch the video and imagine trying to do it some other way. Let's move on. So this is what we are seeing. Now, I want you to bear in mind that there's a lot of noise about this going on in the US, as I said from the 333 it's only been legal for less than a year. So, only commercial use of UAVs, and a very restricted commercial use, in the US, 1 year. So, of course, we're behind. And we're actually about 5 years behind the rest of the world. So, most of these videos are taken in Scotland or England, which is one of the leading agencies. If we look top left, critical infrastructure is what we're talking about. We're talking about power, oil and gas, railways, bridges, utility towers, inspections, water towers, etc. And they have all been inspected on a commercial basis in Europe and beyond. France is very far ahead as well. So the use of some very specialist inspection specific platforms. So Falcon 8 is shown here. There's I think it's probably an S800 on the other side, but they have been used in oil and gas, so inspecting underneath rigs. They have been used in top left for flare inspections to entire site down, wait till it cools, and get somebody to climb up there. Now you can do it while it's still flying, and you can get amazing footage beamed directly to the engineer on the ground that can say, oh, I see that, oh, I don't see that. All the railways in the UK have now been sectioned up and are being inspected by drone by 4 different companies. That happened this year. Bridges, so this bridge at the bottom, just an example, is it's 500 years old. It's in Scotland, and previously to inspect it, they had to put barges out. They had to build scaffolding. And they had to climb all over it, and it took about 2 weeks. It took these guys 2 days to inspect all of it using high definition photogrammetry and camera work, and they've got all of those photos. So, I mean, the utility is incredible. Let's move on. So when it looks, I mean, we're all hazardous fleet working group. We're interested in maintaining the status quo and looking at power. Power is the lifeblood for many, power and roads. Tower and bundle inspection is now commonplace in Europe, and there's a lot of separate power companies looking at ways of doing it. This is us. We've teamed with a group called Cyberhawk, who are probably the world leaders in this over in Europe, and we've worked through their costs, etc. And this is us, actually, our team up in Scotland doing some power line inspections with them. The key, though, if we just step forward in the slide, we can just look on that. Yeah, is what you can see. Now, prior to having this ability, you'd have to, the tower climbers, the linesmen, the journeymen would have to climb up the centre of the tower. The towers are live. You have to maintain a safe separation distance. And you can't see various areas of it. You can manhandle stuff and bang hammers, etc. But these drones allow you to get in close. They are EMI shielded, and there's very little arc risk. But the cameras can show in EO and IR exactly all the bits and pieces of these, the cotter pins, the insulators, etc. It's really quite stunning what you can't fix it, but at least you'll know if it's broken or not. But this is the key. These are 2 areas in, I believe they're both in California, and one's a marsh and one's a river, and these are incredibly difficult to inspect manually. And yet a drone is ideally suited to getting out, looking at these things, even, with a visual line of sight restriction. So there's some tremendous utility, time, cost, and safety saving. And not only that, the most recent drones can operate in, say, 30 knots of wind, whereas tower climbers are often restricted to, I think it's 20 knots. So you can be inspecting them in worse weather than manually climbing. Okay. This is an example. This is I'm an expert, just the second phase of this, actually. It's Minnesota Department of Transport, and they're doing a pilot program to see the inspection of bridges, and these are all taken using a Sky Ranger, this particular piece. And you can see, very simple to use, very complex bridge structures in some cases. You can really get in. We can 3D map them. And I'd like you to just focus on the bottom right here. So you see the where we drilled, it's an old railway bridge now, a walkway, but that is what the zoom functionality in that payload I want to show you. And we were showing these to the engineers, and they were literally gobsmacked. Nobody hanging upside down off a upside down cherry picker on a barge. You can see exactly what the issues are, the design, the build issues, any cracks, any rust build-up, etc. So the capability is stunning. And everyone agrees on this. It's just walking our way through the regulations and getting comfortable with it. That's the issue. Okay. But taking pictures is one thing. The other piece that now the software, both in the aircraft and the software in the GIS platforms, Pic4D, for example, does is it allows you to provide these incredibly accurate 2D and 3D ortho maps, which can be geo-rectified, so you know exactly where every single spot on this map is. And the accuracy is going to stun you. You can zoom in to these pictures, and in fact the top 2 are actually videos, which just I've taken screenshots of. And you can manipulate them in 3 dimensions, zoom right in, and the accuracy is within plus or minus 2.5 centimeters. So, I mean, less than an inch. It's stunning, and these are all taken from like 200 feet. So, all within legal 333 limits, and the accuracy, and if you have some ground control out there, the geo accuracy is absolutely astounding. Better than anything you'll need. But, and then there's plenty more afterwards, in that you can do post-mission analysis of what they're doing, and you can either do that using some of the software pieces, coherent change detection, counting asset management. Another example of talking about post-mission analysis, we'll go on to that next slide, Tom. You'll see this is a Colorado DOT program that we just started, and it's looking at this curve in the road, and there's some scree boulder activity that they're concerned about, landslides. So we did a provisional map of this, and then that was a couple of months ago, we'll go back quite soon, in fact, and do it again. And because of those accuracies, you can do coherent change detection on the point cloud, and you'll see what boulders have moved, and it's incredibly accurate. USGS has been doing this. This is a video of it as it's been rendered, and you can see basically you could fly around this site. So we'll send you the link to that. Speaking of videos, then, we talked about the utility. So again, the other end of the Houston flooding, Blanco River. This is an amateur videographer. The chap showed up. He pulled out his $300 drone, and he took some incredible footage that I'd like to try and picture. How on earth would you get this information, this imagery, understand the true devastation if you didn't have this and you couldn't afford a helicopter? So I commend you to look at the Blanco River video, which again we'll have to link. And finally, of course, we always talk about these drones being used for search and rescue, that they have infrared capabilities, they can search large areas, and you can find lost hikers, etc. But the point detractors always make is that you can't rescue people, because all you can do is search and find, hopefully. So this was to prove them wrong. This is again during the Texas flood. This house is floating away, and one of the fire chiefs flew his own personal drone, the DJI Inspire 1, out using with a little guy line attached, as you can see behind it on the bottom left, and then they pulled out a major harness line on that, and physically tied off the house so it didn't float away anymore. So there you go, our first case of search and rescue. It goes on. Next slide. We sent a team, along with several other teams, but we sent a team down to Nepal for a month after the horrendous earthquakes and the aftershocks. And they were actually out. We did a little bit of search and rescue looking for a downed helicopter, but the key was mapping. It was to look at both the land use and getting an accurate depiction of what actually has moved in the land. So next slide. You can see we've done, let me just click on the next. These are two areas that are mapped both in EO and IR on the same mission, actually, because they've got a joint payload. And you can, though you obviously have to sit down and interpret these things, but you get an incredible amount of information in both those sets. And these, as I said, can be plugged into ortho rectified mapping. And if you get the opportunity to before and after shots, then you get some really quite astounding data that you can use for planning. Next slide. So hazardous materials. There's a tremendous amount of oil train fires in North America in the last couple of years. And this is an incredibly dangerous area to be in on the ground or in the air. And this is where these drones come into their own. You can not only could you use multispectral sensors, EO and IR, to pick where the hot spots are, where the fires are, be through the smoke for the most part in some frequencies. No, you can get in close. You can zoom in on any of these trains, carriages, and find out what was it carrying, what is the labels on the side. And all of this information can be beamed back to the incident commander in live time. So he can be stood next to the pilot in command saying, right, I want to see that carriage move over, let's come there. And also map the entire site so that you can use that for planning purposes in 3D. The hazmat utility of these things for public safety is incredible. And a really good example of this is another video of the Fukushima reactor after the tsunami, and this was taken by a T-Hawk drone, and really watch the link, please, because the devastation is absolutely stunning in a negative sense.
Yeah, Kevin, I guess there was no other way you could get near a blown up reactor than a drone. I don't think there's any other way to do it.
Well, as we were discussing earlier, I heard this apocryphal story of literally old age pensioners volunteering as suicide gangs to go in and clean up some of the mess, knowing that it was lethal within 45 minutes. So there isn't that I can think of. And the utility for what's known as the 3D, the dull, dirty, and dangerous sort of roles, US use cases for drones is, I don't think you can argue about it. And so yeah, this is a really good example. Of course, it all comes together now with the planning P, which I'm sure many of you are familiar with. And of course, when it comes to these responses, where can you fit drones in? Well, you'll be surprised. It really, this is our the drum that we're banging to say, you please adopt these things because you can use them in at least 3 of the areas talked about. So initially, the initial response, if you have your teams trained, equipped, and ready to go, and or you have somebody on the hook ready to go, and Tom, if you can just forward, and in fact just keep going 2 more, that'll be fine. So you can have people out on the initial response team that can give you the incident commander imagery and mapping within an hour of getting on the ground. These things could be airborne, and that information could be in the CIC. And then when it comes to the tactics meeting, preparing, planning for the rescue efforts, you have subject matter experts that have guys in the field that can get information to them immediately, eyes on whatever, which bridges are down, which areas, which power lines have been compromised, and where, what's the right of way for it. There's a tremendous amount of info that can be fed straight into these planning meetings that make it far more useful. No point making a plan if you don't know what the ground, the state of affairs are. And then executing the plan, having these guys, eyes in the sky, as you take the team out, the first responders out, etc., and even follow-on forces as they look to open up new areas. This is a tool that we just have to get our